All right, so this gas law triangle example, I have a balloon with 2.05 liters and 1.50 atmospheres. What is its new volume at 125 kilopascals? So again, we're going to go through that same process. What am I given? 2.05 liters. Liters is a volume, so that's my starting volume, or V1. 1.50 atmospheres. Atmospheres is a pressure, so that's pressure 1. Okay. What is my new volume? So that's my unknown. The ending volume, or the final volume, we don't know what that is. Okay, and I'm going to have it match. Since my volume to start was liters, my volume to end is liters, because they have to match. Okay. And at 125 kilopascals, that must be my ending pressure, because that's when I have my new volume. That's my ending volume. So if my ending volume needs 125 kilopascals, my ending pressure is 125 kilopascals. Oh, but I have a problem here. My pressures don't match. So before I even go on to figure out what my equation is going to be to solve the gas law problem, I have to do a conversion. So I need to use my dimensional analysis. Now I can convert atmospheres to kilopascals, or I can convert kilopascals to atmospheres. It doesn't matter, as long as when you put it in the equation, the pressures are the same units. So I'm going to start with atmospheres, 1.50 atmospheres. And then I'm going to go look on my conversion sheet for the conversion between atmospheres and kilopascals. Atmospheres is in the numerator. It's what we start with, so that means my unknown has to be on, or my known has to be on the bottom. So that means atmospheres has to be on the bottom. Because remember, 1.50 over 1. So you know you have to cancel. So atmospheres has to be on the bottom. Kilopascals is my unknown. I keep saying it backwards. Kilopascals is my unknown. So what I'm looking for has to be on the top. I look on my sheet and it says 1 atmosphere is equal to 101.25 kilopascals. So I put the 1 with the atmospheres and the 101.25 with the kilopascals. Now I multiply across the top and divide across the bottom. So in this case, 1.50 times 101.25 divided by 1, and that gives me 151.875 kilopascals. And now I look at Sig Figs, and when I look at Sig Figs, I only look at what we started with. So 1, 2, 3 Sig Figs. Remember that 0 is important because there's a decimal. So I need 3 Sig Figs here. So I'm going to round that up to 152 kilopascals is equal to pressure 1, because I just converted 1.50 atmospheres into kilopascals. So now I look and I see that I am varying volume and pressure, volume and pressure. So I look at my triangle. There's no temperatures here. There is a pressure and a volume. So that means my equation is P1 V1 equals P2 V2. Okay. S for substitute, that's my next step. P1 is 152 kilopascals. Don't put the atmosphere 1 in here. Almost, you might even want to, after you convert, put a line or something through it so you don't accidentally write the wrong one there. Okay. My volume 1 is 2.05 liters, and that equals my pressure 2, 125 kilopascals, times my volume 2. Oh, I don't know that, so I'm just going to leave it V2. So combining like terms, 152 times 2.05 is 311.6 kilopascal liters is equal to 125 kilopascal times V2. I want to get 125 kilopascals not attached to V2 anymore, so I'm going to divide. What I do to one side, I do to the other. So 311.6 divided by 125 gives me 2.4928 liters because those kilopascals cancel. Last step, Sig Figs. I have 3 Sig Figs for everything, so I am going to answer with 3 Sig Figs. 2.49 liters equals volume 2.